Hey, OChemsters, this is Mrs. Vandelay bringing you a video for OChemsters. We are in chapter 3 now, talking about alkenes and alkynes, all right? It takes all kinds, doesn't it? All right, so section 3.1 is just kind of like an intro to what we'll be talking about and is a definition and classification, all right? So alkenes and alkynes have physical properties very similar to alkanes. These will only contain carbons and hydrogens unless you have some substituted groups in there like a fluorine or chlorine. And so let's just go with the straight CH group, okay? They're going to be nonpolar. Why? Because there's now the big four. What was the big four again? That was your nitrogen, oxygen, fluorine, and chlorine. Those are your four very electronegative elements, all right? But carbon and hydrogen are not included, all right? So they are nonpolar. So what does that mean? They won't dissolve in water. So because they are nonpolar, what kind of intermolecular force do they have? Well, very low attraction. They only have London dispersion. So they don't have a lot of attraction for one another. And so what does this mean? They also will have very low boiling and melting points. They will also have very low viscosity. So if they are a liquid, they're going to be rather thin. But again, the more carbons you have, the thicker they will get. They are going to have a low density. This sound like that lab that we did together. And just like the alkanes, the first four are gases, just like the alkanes, okay? So what about alkynes or alkenes and alkynes? How would I classify them? They are unsaturated. What does that mean? So your folks, I had a typo here. So this is supposed to be alkenes. I think I left out the L. Will have double bonds. And your alkynes will have triple bonds, right? So I want to show you something real quick. This is an alkane. You should recognize that with a CnH22, right? So now what? I want to make an alkene, okay? I need a double bond. Ready? Let's do it this way. Oops, go away. So I need to do, there's my double bond. What do you think, okay? What just happened to my carbons? I bet they're going spastic right now, okay? Wouldn't you agree? Why would that be a problem? How many bonds does each carbon now have? Has 5 bonds. You know you can't do that. So now what? We need to take away 2 hydrogens for that to happen. Did you hear what I said? We need to take away 2 hydrogens for that to happen. So if I start out with CnH2n plus 2, I'm going to take away 2 hydrogens. I'm just going to now have CnH2n. All right, so what if you want to make another an alkyne? You want to have a triple bond. So here we go. Let's say well, it's black now. Sorry, it's not blue. But now you have a triple bond. Once again, what happened? This carbon, each carbon has 5 bonds. You know, in your heart of hearts, you can't do that. So you need to take away 2 more hydrogens. So take away 2 more hydrogens for that carbon now to be all right. And so now I have CnH2n minus 2. So let me just kind of show you real quick. Though I'm going to put those back or those away. And this is really the orientation. We'll talk about this later of an alkyne. The hydrogen, has a linear motion. Why do you think that is? sp hybridization. Oh yeah, we're going to talk about that again, aren't we? Yep. So let's see here. Again, this is going to be a future discussion here, but just FYI, either an alkene or an alkyne can react with hydrogen. I wrote this H-H, H bond and H. That's H2, right? And then you will also get an alkane. So you are adding, oh, that's a key word. You are adding the hydrogens to the double bond, and you can get an alkane from that, okay? Now, what else do we know? That we can form multiple double or triple bonds. All right. So a diene, look at that prefix. What does that literally mean? Two enes, two double bonds. All right. So if I took away, oh, let's go back up here again. If I have an alkene as H2N or HN, I'll say it again, CnH2n, I'm going to put another double bond in it. Don't have to take away another two hydrogens. Yes, I do. All right. So that's what its formula is. Ooh, wait a minute. Mrs. Vanderwey, look at that. Yeah, I see it. They have the same formula, different structure. I bet an alkyne and its equivalent diene are isomers of each other. And you know what? I bet you're right. So then there's a triene with three double bonds, triene, three double bonds, and I'm going to take away two more electrons for that. And guess what a tetraene is, all right? Four double bonds, all right? And guess what its formula is? I need to take away yet two more hydrogens for that to happen. So let me ask you this. Can I have a four-carbon triene? All right, notice that this is a triene, not a tetraene, all right? I have three double bonds. Does that exist? The answer is yes. How do I know that? Let's plug in a number. C4H, well, what's 2 times 4? 8 was 8 minus 4, 4. Yeah, I can have 4 hydrogens. And where will those hydrogens be? 1, 2. All right. Does this one need any hydrogens? No, it already has 4 bonds. Does this one need any hydrogens? No, it already has 4 bonds. Does this one need any hydrogens? Yes, it only has 2 bonds. So there's my 3, 4 hydrogens. So yeah, that's not a problem. That works very nicely. So then we have something called dienes. Now that's kind of hard to say, isn't it? These are polyenes. These are multiple triple bonds. So diene means I have 2 triple bonds. Now what would be our formula? Let's go back up here for a second. So when I started out with my alkane, I had H2N plus 2. When I made my alkyne, I ended up with 2N minus 2. What's the difference in hydrogens? I had to take away a total of 4 hydrogens to go from my alkane to my alkyne. So every triple bond, you are going to remove 4 hydrogens. All right, so then if I have this H2N minus 2, I'm going to take away 4 from there, and I have 2N minus 6. So if I have a triene, I have 3 triple bonds. Again, take away 4 more hydrogens from the diene, and I get CnH2n minus 10. And finally, I have a tetraene. Oops, sorry. Tetraene, that's kind of hard to say. You have 4 triple bonds. And the formula is, are you ready? CnH2n minus 14, because I keep taking 4 electrons away. So my question is, can I have a 4-carbon triene? Well, let's look at this. If I have C4H, well, what's 2 times 4? 8. What's 8 minus 10? Negative 2. So can I have a 4-carbon triene? Can you have a negative 2 hydrogens? The answer is no, you can't. This does not exist. Okay, let's go to the next page. All right, well, speaking of isomers, take a few minutes out and try to draw all 3 structural possibilities of C3H4. Good question. Pause this and see what you can come up with. All right, let's see how you did. Well, I came up with, first of all, a diene, all right, and so once again, only my N carbons will need the hydrogen, so that's C3H4. I also came up with 1 triple bond, all right, and so I put all my H's in there. The end one that I drew it has 1 hydrogen, and the other end one needed all 3. But what did you do about the other one? Ha, I was pretty clever. Oh my goodness, Mrs. Vanderlei, what did you do? I came up with a cyclopropene. All right, but we didn't talk about those. Well, you're right, but we can still have that now. Take a wild stab. How stable do you think that structure is? Not. All right, but does it exist? Yes, but not very fat, or not very for very long. No, it's going to fall apart pretty quick. But that could be yet another possibility. Okay. Now I do want to show you two examples of these alkenes, and what's a huge clue? Look at how they end. Carotene. Have you ever heard of carotene before? All right, maybe, maybe not. All right, well, here it is. What do you notice about carotene? Oh my goodness, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 double bonds. So that'd be like a decene, all right, if you will. So that'd be an 11 double bonds. Holy cow. And what is carotene used for? Carotene is what makes your carrots and your pumpkins orange, okay? And actually, let's say beforehand, well, maybe before you have a ripe, pumpkin, it's not orange, it's more greenish, and that's because the chlorophyll has kind of like taken over. But as it matures, then the carotene takes over, all right? And your eyes perceive that as orange. Oh, I mentioned your eyes for a reason, because carotene is supposed to be very good for your eyes and help your sight, okay? So that's carotene. Now look at this next one. This is a lycopene. Okay, there's lycopene. Take a look at this structure and compare it with carotene. They are very, very similar. The only difference is there is another double bond here, and these are not connected. There is another double bond here, but these are not connected. The head and the tail is what they call it, are not cyclo, okay? And so very interesting. And lycopene has really nothing to do with color, but believe it or not, this is something that is actually used to help with prostate cancer. Okay, so very, very, very similar structures, but very, very, very different properties. Okay, just the fact that the head and the tail are not cyclos makes a world of difference, doesn't it? But what I wanted you to see, that in nature, okay, in nature, what do you notice? You have alternating double bonds. Oh, by the way, I forgot to tell you, lycopene, I believe you can find in tomatoes, all right? So anyway, alternating double bonds. I have a double bond, single bond, double bond, single bond, double bond, single bond. Do you see that? So anyway, we have a term that describes the positioning of these double bonds. The first one is called cumulated. A cumulate is when the double bonds are next to each other. And if you look at both carotene and lycopene, none of them are next to each other. So they are not cumulated, as the examples are here. So let me ask you this. Can alkynes not have cumulated bonds? And the answer is, well, no, they can't. We already said that. Do you remember what happened when I tried to do the 4 carbon with the 3 triple bonds and we ended up with negative hydrogens? Let's take a look at the structure then. What's wrong with this structure? This carbon has 3 bonds, so a hydrogen could go here. But what's wrong with these 2 middle carbons? They already have 6 bonds. Can that exist? And the answer is no, it cannot. So write that down. The alkynes cannot have cumulated bonds, because then carbons are going to have 6 bonds, which is impossible. So I'm going to put a big fat red X there. All right, did you catch that? Can't happen. All right. So then we have another term for conjugated, which is an alternating with single bonds. All right, so let's go up here again and look at this. Double, single, double, single, double, single. These are conjugated. All right, did you catch that? They alternate between double and single bonds. All right, so that works great here. And so while we're at it, let's go ahead and put some hydrogens in. How many hydrogens are going to go here? 2, How many are going to go here? 1, 1, and 2. Does that work? Yes, it does. Every carbon now has 4 bonds. It's not overloaded. How about a conjugated alkyne? Does that work? Yes. I can put 1 hydrogen here. Hey, how many bonds does that carbon have right now? It already has 4. It needs none. This carbon has 4. It needs none. This carbon has 3. It needs 1. It works. So you can have conjugated alkenes and conjugated alkynes, okay? So finally, we have something called isolated, and that's if it is just however it works. All right, there's no pattern, let's say. So if you have multiple single bonds between, that would be an isolated or a non-conjugated form here. So notice I have 2 single bonds, and I have, looks like 3 single bonds between the alkynes. So problem number 3 says, which of the following compounds have conjugated multiple bonds? So take a few moments out and make your choices. All right, did you say A? Yep, has alternating. B does not. This would be your isolated, all right, because you have 2 single bonds between the double bonds. This is, notice you have double, single, double, single, double. Yeah, that is. And this one's note only has 1 multiple bond anyway, so that doesn't count, okay? And that concludes section 3.1. So don't wait to be great. We'll see you next time. Take care, everyone. Bye-bye.